Welcome to our technical deep dive into the Google file system architecture. Today, we'll explore the distributed system that helped Google scale its operations to unprecedented levels. Let's break down these complex concepts into clear, practical understanding using a familiar, analogized modern library. Imagine you've stepped into a giant futuristic library. In this library, the librarian is the all-knowing authority. They know exactly which room holds which book and which assistant can get it. Library assistants help visitors, you and me, find and fetch books. They do most of the running around. Rooms are where books are stored. Each book is chopped into parts and placed in multiple rooms just in case one room becomes inaccessible. Visitors are the constant stream of people requesting books. These are like our data read and write requests. So here's how it works. When a visitor comes in with a request, the assistant doesn't search the whole library. Instead, they ask the librarian. The librarian doesn't hand over the book. They give directions room A, shelf 2, and just in case, also check room B and room C. And just like that, the visitor gets what they came for without ever dealing with the library's complexity. Now let's translate this into GFS terms using the actual architecture. The librarian is the GFS master server. It manages all metadata, file names, file-to-chunk mappings, and the location of each chunk replica. Library assistants are the GFS clients, the applications or users that interact with the file system. Rooms are the chunk servers. They store the actual data, called chunks. Each file in GFS is split into fixed-size chunks, 64 MB by default, and each chunk is replicated across multiple chunk servers for reliability. Visitors are the read-write requests made by users or applications. When a client needs to read or write a file, it doesn't go directly to the chunk servers. First, the client asks the master for the locations of the chunks it needs. The master replies with the metadata, not the data itself. The client then communicates directly with the appropriate chunk servers to perform the actual read or write. This separation allows the master to stay light, handling only metadata, while chunk servers do the heavy lifting. Even if a chunk server fails, the system keeps running smoothly because there are multiple replicas of each chunk. The master regularly receives heartbeats from chunk servers, ensuring everything is up to date. And if any chunk server goes offline, the master re-replicates the chunks elsewhere. Now that you understand how the GFS system works through our library analogy, let's pull back the curtain and look at the real thing, the actual architecture from Google's original paper. On the left, we have the client. This is the program or application that wants to read or write data, like our assistant walking into the library. In the center, you see the GFS master. Just like the librarian, the master knows the entire layout of the system, which chunks exist, where they're stored, and who's responsible for handling changes. When a client wants to access a file, it first contacts the master. But the master doesn't give the data directly, it responds with just the chunk locations and who's currently the leader for any write operations. At the bottom are the chunk servers. These machines actually store the file data, broken into large, fixed-size pieces, called chunks, each identified by a unique chunk handle. Once the client knows where to look, it bypasses the master entirely and talks straight to the chunk servers to read or write the data. This direct path keeps the master from being a bottleneck even when thousands of requests are flying in. For writes, the master assigns a primary chunk server the one in charge. It grants this server a lease, which is basically a time-bound permission to coordinate the write. The primary orders the write operations, then forwards the changes to the other replicas to make sure all copies stay in sync. To keep track of everything, chunk servers regularly send heartbeat messages to the master like saying, "Hey, I'm alive and I have chunks A, B, and C." If something fails, the master notices quickly and can automatically create new replicas elsewhere. This architecture with a single master, many chunk servers, and smart clients is what makes GFS efficient, scalable, and fault-tolerant, even at Google scale. So behind the scenes of your favorite search results and YouTube videos, systems like GFS are quietly working, organizing, storing, and retrieving information like the most reliable librarian you'll ever meet. And that wraps up our deep dive into the architecture of the Google file system. From librarians and assistants to metadata and chunk servers, we've seen how GFS is built for reliability, speed, and scale. Thanks for watching, and I hope this visual breakdown made the inner workings of GFS a little clearer.